Hello everyone, Mike Stokes with Lush Planet Design Build, and today I'd like to make a video about our latest build. As you can see behind me, it's a deck specifically designed for a jacuzzi to take advantage of the view behind a house here in Northern California. So I'm going to go through all of the, from beginning to end, all the little details which I think might be helpful for those of you who want to build a deck. So everything starts with the foundation. So we laid out a perfect square with level lines all the way around the base here. And set our posts. There's another video of how to set your posts plumb in the center of your hole, so watch that if you want to see more information about that. You'll also see on this one post base here the charring and tarring technique that I use. Basically we char it like a shishugibun, Japanese style charring treatment to preserve the wood, and then we put a Henry's emulsifying tar on that, and there's another video you can watch about that as well. So we laid out the whole foundation and then dug the holes and set the posts and then poured the footings around the posts. In this particular design I chose not to use post bases because of the railings. I wanted the railings to go up and be integral, and I wanted a little bit less movement. And if you see the back, those posts go all the way up to that architectural feature in the back, and so I wanted them to be integral into the ground so they had a little bit more shear. They really don't have that much more shear, but it just helps keep them a little bit more solid since we didn't have a lot of other shear in the design. What I mean by shear is there's no 45s. So a 45 that goes this way and that way, if you're not familiar with the concept of shear. The design called for not much shear, so that's why we did that. Another thing that's really interesting about shear is that the decking from here forward, the framing and the decking actually acts as a shear. So the deck itself doesn't want to move like this because it's a box that sits on top of it. Now the posts could still move a little bit, and then the railing itself, the metal frames, they act as little shears too. So if the whole thing tries to twist like this, it actually will butt up against the railing. So there's a little bit of shear value there. And then also, since we had it attached to these stairs, that created a little bit more shear. The design that we were going for required that we didn't put the 45s on there because it would look a little too busy. We wanted to keep the lines as clean and as simple as possible. All the wood that you see is FSC certified redwood or locally milled at our local mill. I think with it, for the exception of the posts, I got FSC certified. If you look under here, just standard 16-on center framing. And then in the back, which you can kind of see, I put an extra footing here and an extra beam in the middle and an extra footing on the back and then an extra footing between these two posts on each side because there's going to be a jacuzzi back there. So I designed this front section to be at 50 pounds per square foot, which is a standard deck load, and I designed the back section to be 100 pounds per square foot. Basically, to keep it simple, I just doubled all of my points of where the load was distributed into the ground so that it would add up to 100. Something you'll see here which is my own design, I actually chose to put footings, not footings, is the wrong word, hangers for my beams. Now, some may argue that that's not enough structural support, but in this particular application, it's going to be fine. It's going to last. If something dies, the first thing that will die will be the post base at the ground. But this thing is going to last, you know, and in worst case scenario, if this thing over 10 or 20 or 30 years turns out to not be enough, I can always add another 2x4 all the way down to the ground there, or just a 2x4 sister to keep it solid with some bolts holding it on. But it'll work just great. So that's the foundation, the posts, the footings, the posts, the framing, and then let's go up to the decking, because that's the next thing that we built. I really like a 5/16 space. So if you see these spaces here, that's a 5/16. I use these nifty little blue deck spacers, and that way I find so often when I come to a deck and I have to fix it, that this is clogged with dirt and it's just rotting from the bottom up. So that gives you more airflow, which in exterior wood exposures, the biggest problem is lack of airflow and lack of sun exposure. So if you're in a shady spot, which is this is kind of shady, and it doesn't dry out very well, then these rot out a lot faster. But I think with this airflow and this particular design, this deck should last, oh, hopefully 50 years. 50 years would be nice. So then let's move on to the railing, because that was the next thing that we did. So you'll see that in these railings here, we used the standard 4-inch utility panel, which is pretty common in our area. It's the cheapest way that you can make a nice looking code compliant railing. And what we did was you just cut it to size, and then I took some scrap redwood that I had and then just ripped it down on the table saw till it was 3/4 by 3/4, and then sandwiched it in, and then galvanized finish nail them off all the way around both sides. So that's it. And we used just a grinding wheel to cut the utility panel. Standard railing deck. So then the next thing that we did was build this architectural feature. Basically a 4x8 redwood, mitered and placed on top of 4x4s. And there's 2 long screws that go down through the top into the 4x4 on each of the 4x8 architectural features. Now that, you may say, well, that doesn't have any shear value. Well, yes, it doesn't have any shear value, but we're not using it for anything except hanging curtains. So it's fine. And then one caveat, I was grinding these metal things on the redwood decking, and the little metal shavings got in here, and really I've cleaned this up a lot, but it really turned this black. So don't grind metal near your redwood or other woods if you don't want it to turn black. Just a note about the building of these stairs. So the complicated part of when you're building stairs is calculating the rise and the run in relationship to where your landing is. So in this particular application, I had to come up with the rise and the run to a landing, and then the rise and the run down to another landing. So, oh, now I'm forgetting how I did it. Well, the first thing that I did actually was, now I remember. So we had this drainage channel on this side. So basically, I wanted this pad to be as far out as I could because I have quite a slope. It was a challenge to keep is the slope goes all downhill. So it was quite a bit of a challenge to make sure that as I changed the location of here's this footing, of the bottom footing, that it just, if I moved it farther down to make my treads longer, that it would just move down the hill and make more stairs. So what I did was I moved this platform as far out as I could so that I could get the longest stairs over here on this side. And then I built this. I just built, when I say this, I mean the landing. So I built the landing. Landing was built. Then I built the treads to the landing. And then I built these stair treads down to, well, then I built the next landing and then built these treads down to that landing. It's not too complicated to do. You basically, there's always a couple little things that can trip you up when you're building stair treads. So for example, this stair tread right here goes down and is attached to the face, and normally they kick out and don't have this extra piece right here. So I had to calculate for that when I built the treads. So you can see on this one, this would be a standard tread where you cut the bottom. You cut the bottom of this, you calculate it first, and then you cut this 1.5 inches off so that you make it right size for the tread height. So I don't know if that made sense, but another time I'll post a stair tread video, and I'm sure there's a lot of other stair tread videos which you can watch. So moving on, so there's our stairs. I'm really happy with the way they came out. An interesting challenge that we ran into was these posts were with so much downhill that we had, these rail posts were too far back. So we had to extend the rail caps out and then put in these little 45s. And that's what I often find when you're building, is that you've got to sometimes design things on the fly. And so that had to be designed on the fly to give us a little bit of extra rails, or you wouldn't have any railing for those first 2 steps. But I think it works good. I like the way it came out. And then the last thing we did was we built these treads down the hillside. Well, that's not the last thing we did, but that's one of the things we did. And we came up with sort of an interesting way to do this. I don't know if you'll be able to see it, but there's a 5/8 rebar driven in there, another 5/8 rebar driven in there, and then we found that it wasn't solid enough. So right here, there's another 5/8 rebar that's driven in at an angle, but still goes into the ground. So now there's shear value. So those pieces of rebar will push against themselves if it tries to go down the hill. If you just put them straight down, then they didn't quite give as much stability as I wanted. And I'll come down the hill and we'll look at one last thing that we did, which was kind of an interesting design challenge, which may be interesting to some of you. I don't think I have a picture of how this used to look. But we have this weird little corner here. So let's see if you can see it. So you can see the finished product there. Those are the landscape stairs that we built. And originally, this little retaining wall went out to about here. And then they just had a couple of little steps that sort of went awkwardly up around the retaining wall that were really tall. And I struggled for a long time to figure out what was going to work, because when you're designing stairs in a corner, if you try to turn them, then you get these little weird stair treads in the middle that are trip hazards. So that's why I ultimately went with this angled one. So if I didn't put this angle in here, it was going to be way too close to the house. So I went with the angle, but then a straight stair, and then a landing, and then a stair over here. So that way there's no trip hazard. So that's really it. So let's just take a look. You can sort of see there's the deck up there. And Let's turn the camera around. Hopefully I'll find my face here. So that's it. Thanks for watching. I hope that was helpful. If you have any questions, feel free to put them in the comments. Have a great day.